Last time we have completed the programs for converting the infix, postfix and prefix expressions into each other. So we have covered in all 6 conversions. Effectively those are only 2 programs, that is what we have seen. But the supporting functions are many. Like in case of conversion of infix expression, we require almost all types of functions because it is the only program. When you try to convert infix expression, it is the only program which uses both the stacks, operator stack as well as operand stack. Whereas the conversion of postfix to prefix and postfix to prefix and infix, and prefix to infix and postfix, those 2 programs will simply require the operand stack. They don't require operator stack. The priority concept comes into picture only in case of infix expression, and it is not there in postfix and prefix. Right? So far as postfix and prefix conversions are concerned, we require only 4 functions to operate on the stack. We require the form infix or form prefix type of function, and then directly main, nothing else. Whereas in case of conversion of infix, you require almost 4 functions, rather 2 functions, that is stack empty, stack full, then 2 push functions, 2 pop functions. You require priority function, and you require the form infix or form postfix type of function. So all those functions will be required, and infix expression conversion will be the longest program. Okay. So today we will go ahead with some revision type of programs on the linked list. Write down applications of linked list. Applications of linked list. Number 1. Addition of 2 polynomials. Addition of 2 polynomials in single variable. In single variable. Into bracket. The polynomials should be sorted on power. Comma, each node represents 1 term. Each node represents 1 term of the polynomial. This is the first one. Second, to multiply 2 polynomials. To multiply 2 polynomials. Of course in single variable. Third, addition of polynomials having 2 variables x and y, x and y. This is what we want to do today. Now say if the polynomial is of the type 4x cubed minus 7x plus 12, then it will be represented in the linked list form as each node will have 2 fields, coefficient and power, and will have a pointer to the next node. It is arranged in the descending power, so it is a sorted linked list. Similarly, there could be 8x raised to 5 plus 14x raised to 4 minus 7x square plus 15x minus 31. Then again there will be a linked list, each node having 2 fields arranged in descending powers. It is not necessary that the user should input the data in the descending powers. You should be taking the care that the nodes are arranged in the descending powers. User may input any field, any term at the beginning. User may start with -31, say in case of second polynomial. So ultimately, the structure will have float types coefficient, int types power, and of course struct polytypes pointer to the next node, which I will declare as new type poly. And then you will write the functions like getNode as usual, function like read polynomial, which is as good as create sorted. So refer to create sorted and write read polynomial, generate a new node, accept the coefficient and power, and then place that node as per the descending power. That particular create sorted was arranging the terms in the ascending manner. We are not comparing the coefficient at all. We will read coefficient and power and create the list, so it is as good as create sorted. So this one function you will have to write, read poly you will have to write, and then add poly, where you will be passing the two headers. It will add the two polynomials and will generate a third list and return its header. This will also return poly. This is again a poly type function. This is again a poly type function. All of them are returning the pointers. This will return one node pointer to it. This will return the header node. This will also return the header of the resultant. When you add, you will have to set temp1 and temp2 at the first node. Compare the two powers. If they are equal, then add the coefficients and generate a new node with that power. But in this case they are not equal. So in the third list, I will have the first node as this one, 85. The higher power node will be transferred, copied. Then temp1 is still here, temp2 is here. Again this power is higher, so you will copy this node. Then these two, this is higher, so this will be attached. I will better change this here. Now the powers are equal. In that case, you will copy the power and add the coefficients and increment both. This logic is quite similar to something that we have already studied. Okay, actually it is a logic similar to merging. Only thing is, in case of merging, if we have equal elements, then we used to add both. So there will be two positions. Here when the powers are equal, resultant, there will be only one node generated, coefficients are added. Okay, and one of the list is likely to get over at the beginning. The remaining list should be copied. Okay, so three functions for this case. Then in multiply, this is for addition. For multiplication, you will take one node from here, multiply it to all the nodes and generate a list. So first node will be of power 8, second of power 7, power 5, power 4 and power 3. Next time when you multiply 2 into 5, it is again power 7, which is already there. And so the new coefficient that you will get, that should be added to the existing. So I am not asking you to write multiply. I am expecting that you should be writing these three functions so that the job will be over. Then I will tell you if there is any mistake. But stick to this policy temp1, temp2 and proceed. Everything that we have already discussed actually, but it is the application. Then I will give you the code for multiply, and then we will think about the polynomial in two variables, the terms like 4x cube y square minus 7x square y, etc., etc. That will be the third case. So write these two. So what was the difficulty level of this program? It's as good as creating a sorted linked list and at the most going for merging of the two lists. Okay. If you have written this read poly function, check that you must have written poly types h, n, temp. You must have created the header node. Okay. Then there could be a do while loop. You must have created a new node. Then you must have accepted the coefficient and power. Then you would have set temp to header. And then there is a time to check whether the temp arrow next, if you have really copied it or read it from the previous one, it is while temp arrow next not equal to null, indirectly actually, while temp arrow next and temp arrow next arrow power is greater than, over there it was less than, it is greater than n arrow power, then temp equal to temp arrow next. So wherever you stop, after that temp position n should be added. So there are two statements, n arrow next equal to temp arrow next and temp arrow next equal to n. Then there is a question, any more term to be added, not node this time, it is the next term of the polynomial, any more terms? If yes, it is while get ch equal to y, and you will go back to that do, and then at the end you will be returning h. That is how the program will be. Whereas the add poly program, it will be passed with two headers h1 and h2, and you will pass header of the first polynomial, header of the second polynomial. It is third header, then temp 1, temp 2, temp 3. You will obviously create the third header and then you will set temp 1 to h1 arrow next, temp 2 to h2 arrow next, and temp 3 to h3. Okay. So in the existing two polynomials you will be at the first term, whereas in the third polynomial which you are generating you will be at the header. Now you are required to compare the two powers, and there will be three cases. Either the powers are equal, or first power is greater, or the second is greater. You can go either way. So I will write down the condition after this. It is under the condition that none of the polynomial has ended. So it is while temp 1 and temp 2, just like our merging case. So while temp 1 and temp 2, those who have not written it, for them I am dictating it slowly. So while temp 1 and temp 2, next line opening curly bracket. Now check which power is greater. So I will say if into bracket temp 1 arrow power greater than temp 2 arrow power. Now see, in all the three cases, whether the powers are equal or temp 1's power is greater or temp 2's power is greater, you are required to generate a node. Node to generate karna hi karna. So n equal to get node 3 बार लिखने के बजाय you could have written it before that if. So while temp 1 and temp 2 opening curly bracket n equal to get node, and then you start with the comparison. That is, if temp 1 arrow power greater than temp 2 arrow power, in that case opening curly bracket n arrow coefficient equal to temp 1 arrow coefficient, n arrow power equal to temp 1 arrow power, and then temp 1 equal to temp 1 arrow next. We will not attach n right now because n should be always attached after temp 3. So that job we can do afterwards, otherwise that you will have to write 3 times. N arrow coefficient equal to temp 1 arrow coefficient, n arrow power equal to temp 1 arrow power, temp 1 equal to temp 1 arrow next, closing curly bracket, else I will say if temp1 arrow power is less than temp2 arrow power, if temp1 arrow power is less than temp2 arrow power, next line, opening curly bracket, n arrow coefficient equal to temp2 arrow coefficient, n arrow coefficient equal to temp2 arrow coefficient, n arrow power equal to temp2 arrow power, and temp2 equal to temp2 arrow next. Close curly bracket, else, opening curly bracket. Now the temp1's power is neither greater nor less, that means it is equal. So no need to write any condition. It will be n arrow coefficient equal to temp1 arrow coefficient plus temp2 arrow coefficient. N arrow coefficient equal to temp1 arrow coefficient plus temp2 arrow coefficient. N arrow power equal to काय गेलेलं हा पॉवर पुढे काय काय लिहिले वाच ना जरा. n arrow power equal to फक्त तेवढंच लिहिलंस तू. हा, powers need not be added. n arrow power equal to temp1 arrow power semicolon, temp1 equal to temp1 arrow next, temp2 equal to temp2 arrow next. Closing curly bracket. Coefficient to be added, power both are equal, you can copy any one, and increment both, that is temp1 equal to temp1 arrow next, temp2 equal to temp2 arrow next. Closing curly bracket. Now this n should be attached after temp3, and temp3 is always at the last position, so you can simply say temp3 arrow next equal to n semicolon, and temp3 equal to n, and after that temp3 will point to the last node. Closing curly bracket. Okay, so either both the pointers have incremented or only one of them has incremented. We are running this loop till one of the list gets over. Now if the first list gets over, then temp2 will not be null, and if second list gets over, then temp1 will not be null. And so you are required to write something like this: while temp1, that means if the first list has not yet ended, in that case you will again generate a node, then you will copy the coefficient from temp1, you will copy power from temp1, you will attach this n after temp3, you will increment temp1, and you will set temp3 to the last position. That is, if the second list has ended and not the first one. But it could be other way around also. You can again have while temp2. So if the first list has ended, that is temp1 is null, then it is a similar thing that is to be rewritten, temp1 replaced by temp2, and that will complete our task. At the end, return h3. That is how the code will be. It is identical to merging of two sorted lists, except that equal to condition has to be checked. Over there was no equal to check. So that was the first task. Second, to multiply two polynomials. I will give you the steps, and accordingly you are required to write the code. this algorithm is going to be either in English or partly in C. Okay, when English is easier, we'll write it like that, and when C code is easier, we'll write it like that. Because search for a node, and suppose the node is found at temp 3, then replace the values. This will become a complicated English type, because the meaning will be difficult. Usse to acha hai ki I can directly go on comparing the power. You can always check that if temp 1, while temp 1 arrow power is not equal to n arrow power, temp 1 equal to temp 1 arrow next. That means it will be terminated when the powers are equal. And then I can simply copy coefficient and power. That will be easier. So sometimes in C, sometimes in English, this is what we call it as the algorithm written in pseudo C. So we are not going to concentrate much on the syntax or the semicolons. Wherever you feel that this group of statements should be together, you can use curly brackets, though these are the English statements. So you can have a block. Like in if, on true you want to have 3-4 statements. So when you write it in English, it becomes difficult as where to give the full stop and where to terminate it. So what we do, if so and so condition, opening curly bracket, step 1, step 2, step 3, step 4, close curly bracket. That means this is the block to be executed when the condition is true. So pseudo C it is English like C. So it can be a mixture of the two with the totally loose syntax, but you can always use some part of the syntax like block markers, etc. Okay, and instead of writing complicated C code, you can write it simple way. Okay, instead of writing the code for append the node, you can write it in English, append this new node to the existing list. So we are not going to write anything. Search for a node having so and so power. Say it is found at temp 1, but then the complications start. If it is not found, so those cases you will have to write. Over there C code, C conditions will be easier. Okay, write down step number 1. Create header for the resultant. Create header for the resultant, say H3. Step number 2. Temp 1 equal to H1 arrow next. Step number 3. Temp 2 is equal to H2 arrow next. Next step. So I am at the beginning of both the lists. Now I will have to check, because when I start multiplying, see the cases. For the first multiplication there is no problem. Temp 1 ये है, ये temp 2 है. So I will multiply. So generate a node and add. So 32 power 8. Next. Multiply 56 power 7. Like that. So for the first pass there is no hassle, because every time the new node will be generated when you multiply it by the first node. Problem starts when you go from the second node, because in that time minus 7 into 8 minus 56 and the power is 7. You will have to search for that power 7. Okay, but when you write the code for the first time, you will have to make a note that you will have to search for the power, and if the power is not present, you will have to append the list, because this will be always generated in the descending. See, highest power multiplying all, that will be in the descending. Then the next one, when you multiply, you will have to search for the value and create it in the descending manner. It will not be always added, because sometimes some power is not available, like here power 8, 7, 5, power 6 is missing. So next time when you multiply by 2, 2, 4, power 6 wala node will be generated. That should be inserted in between. So you will have to take care of insertion. You will have to take care of existing power. If the power exists, multiply the coefficients and add to the existing. If the power is not present, then find out the appropriate position and add the node over there. This is how we will have to proceed. What I have done up till now is I have just set the pointers. Now I will have to check whether what the third list contains. Okay, like in the creating in the descending manner. So I will start with temp3 equal to h3. Next step. While temp3, while into bracket temp3 arrow next, and temp3 arrow next arrow power is greater than temp1 arrow power plus temp2 arrow power. See, the resultant node will have the power as the addition of the two powers. So while temp3 has the next node and temp3 arrow next arrow power, that is the next node's power, is greater than the summation of the powers of these two. Of course, for the first time power is 8 and temp3 arrow next is null. So this, we won't be entering this loop for the first time. Okay, I will say close bracket, next line, temp3 equal to temp3 arrow next. It is in the same step. हाँ, ये while एक step है मेरा. Here I am going ahead with two checks. Okay, whether I am ending up with the list, that is I am reaching the last node, or whether the next node has got power less than or equal to the summation of the powers. It is not less always. It could be equal also. Because I am checking, I am taking a step ahead. This is what you have written in add poly also. The same loop you must have written. Only thing is there was no addition of powers. You were just checking with one power. बाकी तो same ही था, greater ही था. So as long as it is greater, take a step ahead in temp3. Next step. Now I am checking that temp3 has got next and that next has got equal power as the addition. So that I will deal with the addition of coefficients. So write down, if temp3 arrow next and temp3 arrow next arrow power and temp3 arrow next arrow power equal to temp1 arrow power plus temp2 arrow power. इसका मतलब है नेक्स्ट नोड की जो पावर है temp3 arrow next arrow power equal to temp1 arrow power plus temp2 arrow power. That means उस power वाला term already present है. So you will have to simply multiply the coefficients and add it to the existing coefficient. Write down. Then temp3 arrow next arrow coefficient. Then temp3 arrow next arrow coefficient plus equal to, मतलब उसमें ऐड करो temp1 arrow coefficient into temp2 arrow coefficient, temp1 arrow coefficient into temp2 arrow coefficient. So both the nodes are processed. So increment in okay, let it be. Rendo temp3 arrow next arrow coefficient equal to plus equal to temp1 arrow coefficient into temp2 arrow coefficient. Okay. Else, now else there are two possibilities. That means the powers are not equal, but we are still at temp3 arrow next. So temp3 arrow next होगा या नहीं भी होगा, तो भी एक नया नोड जनरेट करके आपको अटैच करना होगा temp3 के बाद. So else opening curly bracket n equal to get node, n arrow coefficient equal to temp1 arrow coefficient into temp2 arrow coefficient. So multiply the coefficients, add the powers, n arrow power equal to temp1 arrow power plus temp2 arrow power and then n arrow next equal to temp3 arrow next. I am attaching the node after temp3 and temp3 arrow next equal to n. closing curly bracket. So when I reach a particular point, possibilities are either I have that power, in that case multiply the coefficients and add it to the node. If not, wherever I am stuck up, uske baad I should be adding the node with that new power. So only two jobs, either add the coefficient to the existing term or create a new node and insert after temp3. So that job is done. Next step. temp2 equal to temp2 arrow next. So temp1 मतलब फर्स्ट लिस्ट में से एक नोड ने अभी सेकंड लिस्ट में से एक नोड को मल्टीप्लाई किया. नाउ यू गो अहेड इन द सेकंड लिस्ट टू द सेकंड नोड and again check the same thing. So temp2 equal to temp2 arrow next, and then if temp2 is not null, next step, if temp2 is not null, go to I suppose it is step number 4 होना चाहिए. स्टेप नंबर 4 क्या है? temp3 equal to h3 होगा ना? हाँ बराबर. गो टू स्टेप 4. बिकॉज स्टेप 3 को जाएंगे तो temp2 फिर से इनिशियलाइज हो जाएगा. आई एम नॉट गोइंग टू स्टार्ट अगेन इन द सेकंड लिस्ट. ओके, सो temp3 इक्वल टू h3 को ही जाना है. अब जब ये लूप खत्म हो जाएगा तो नेक्स्ट स्टेप में आएगा वो एल्स. सो इसका मतलब है सेकंड लिस्ट इज गेटिंग ओवर. इंक्रीमेंट द फर्स्ट वन. temp1 इक्वल टू temp1 arrow next. temp1 equal to temp1 arrow next. Next step. If temp1 is not null, go to step 3. अब क्या होगा देखो कि सेकंड लिस्ट खत्म हो गया, इसलिए फर्स्ट लिस्ट में से नेक्स्ट नोड लिया मैंने, एंड इन द सेकंड लिस्ट आई शुड स्टार्ट फ्रॉम द बिगिनिंग. दैट मीन्स आई शुड गो टू दैट स्टेप temp2 equal to h2 arrow next. That was step number 3. ओके, सो ये लूप इनसाइड अ लूप, दो फॉर लूप वाला हमारा चलता है वैसे ही चलेगा. इट इज while temp1 फर्स्ट लूप एंड while temp2 इनर लूप, और उसके अंदर वो कंडीशन चेक करेंगे. ये सब कुछ हो जाने के बाद व्हेन द फर्स्ट लिस्ट गेट्स ओवर, रिटर्न h3 एंड योर जॉब इज डन. सो नाउ राइट द फंक्शन प्रॉपरली एंड थिंक ऑफ द नेक्स्ट केस. व्हाट विल हैपन व्हेन देयर आर, ये अभी मत लिखना, बाद में लिखो आप. व्हेन देयर आर टू वेरिएबल्स, terms like 4x cube y square, it will have coefficient and two powers. Structure will have float coefficient and int px py, power of x and power of y. Now the two terms will be added when बटबंड नको करूँगा काय बोट क्लबला बसलीस का. when power of x and power of y in both the terms are same, another term of x cube y square can be added to this. So you will have to compare both the powers, both px, temp1 arrow px should be equal to temp2 arrow px, and temp1 arrow py should be equal to temp2 arrow py. Then you can add. बराबर है? That is the condition. अब यह कंडीशन अगर आपको समझ में आ गई है तो दिस इज क्वाइट सिमिलर टू एडिशन ऑफ टू स्पार्स मैट्रिसेस, बिकॉज दिस इज रो नंबर, दिस इज कॉलम नंबर, दिस इज वैल्यू. वहां भी ऐसे ही था, रो नंबर मैच किया और कॉलम नंबर अगर इक्वल आ गया तो दो एलिमेंट्स ऐड होते थे. ये जो असाइनमेंट अभी थर्ड दिया है मैंने आपको, दैट इज एज गुड एज एडिशन ऑफ टू स्पार्स मैट्रिसेस यूजिंग लिंक लिस्ट. पूरा का पूरा प्रोग्राम वही है. डॉट रो के बजाय डॉट px, डॉट कॉलम के बजाय डॉट py एंड डॉट वैल के बजाय डॉट कोएफिशिएंट. ऑफ कोर्स वो मैट्रिक्स से लिखा था, ये एडिशन ऑफ स्पार्स मैट्रिक्स लिंक लिस्ट से लिखने का तरीका. एंटायर लॉजिक सेम. पहले आप रो नंबर्स चेक करोगे, दैट इज px आर इक्वल, देन चेक py, जिसका py बड़ा होगा वो कॉपी करेंगे. इफ py's आर ऑल्सो सेम देन ऐड द कोएफिशिएंट्स. ओके, अदरवाइज इफ px आर नॉट इक्वल देन चेक विच px इज स्मॉलर, कॉपी दैट नोड. जो हम k1 k2 k3 से कर रहे थे, एग्जैक्टली द फुल कोड लाइक दैट. वो सिर्फ हमारा एरे से था, ये लिंक लिस्ट से है, लॉजिक डज नॉट चेंज। वहां हम एरे में K1 प्लस प्लस करते थे, यहाँ temp1 इक्वल टू temp1 एरो नेक्स्ट करना पड़ेगा। ओके, सो जस्ट थिंक ऑन दिस। ओके, दैट विल बी अवर सेकंड जॉब। लेकिन पहले आपको वो मल्टीप्लाई फंक्शन